All right, welcome back to just another solar podcast with Luke Beattie. That's me, Karl Jensen. G'day, Karl.
Luke, how you going? We've got some
Um,
sun this week, mate. 2 warm days, 38 degrees. Had to blow the cobwebs out of the air conditioner. I filled the spa up, filled it up with the water straight out of the heat pumps. Amazingly, I did a bit of a experiment and started the stopwatch from stone cold to full temp. And
mhm.
in 35-degree ambient temperatures, I get COP6, which is unbelievable. Every kilowatt of energy I throw at it, I get 6 kilowatts of heat into the tank, which is, yeah, just awesome.
And g'day, Nigel Morris, or industry legend Nigel Morris.
G'day, fellas. G'day, Luke. G'day, Karl. I'm
Whereabouts in the world are you?
down in Adelaide today. I've been on the road all week. I started yesterday morning with about 8 degrees in Glen Innes up at the factory, the Catch Power factory, where we went up to have our annual planning session and a Christmas party and a whole lot of fun. And then went to Brisbane, where there was 180 millimetres of rain in 2 hours. And now I'm in Adelaide for a shindig tonight, and it's 38 degrees. So got all seasons in almost one day.
And that shindig, that's the 10-year anniversary of NRG Solar.
Sure is. It's becoming a bit of a thing going to these parties where companies are, 10 or 15 or 20 years old. Who'd have thought it, eh? But great to be celebrating with everyone at NRG. It looks like Eddie's going to throw on a good bash for us. It's cocktail attire, so I had to dig out a tie and
You're not going to
and
wear that Ramon shirt.
no, I'll change the Ramon shirt. Yeah, yeah. So that should be fun. And out there at the Adelaide Cricket Ground, great venue, amazing venue. So it should be great fun.
Yeah, nice. So you got to mention Catch Power before I did. I wanted to bring up the Vic backstop. That's come into effect, and we're hearing that there's lots and lots of issues. So it doesn't matter which solution you use in, there's been some sort of teething problems. But obviously, Catch Power is partnered to operate the backstop for a lot of these companies. What sort of feedback and challenges are you seeing, Nige?
Yeah, it's an interesting one. I mean, certainly we're seeing some go through no problem at all, and yeah, it's pretty exciting to watch the number of CSIP connected sites, as we call them. CSIP's the operating protocol that we use to ramp things up or down or turn them on or off. And it's amazing to see the number of sites coming on board. That's great news. But of course, inevitably, we're also seeing teething issues. And, I was chatting to an installer today who said that he'd gone through the commissioning process with us. Everything went fine. It automatically triggers the network company and says, okay, this is in, here it is, recognize it, give it a quick test. Yep, everything's good. And then there's a final loop of tests and connection, I guess, where the DNSP then ramps the site up from zero and allows it to go into full export mode. And some of those tests are taking 20 days, which is an awful long time. Yeah, it's kind of inevitable when you roll out new programs that there are these kind of bugs and teething issues and stuff. But I'm imagining, or I'm hearing, that there are a bunch of frustrated installers and presumably owners out there saying, geez, I wish my solar would just work.
Even worse, Nigel, because you've got all of these different manufacturers and then you've got all of these different grid areas. The problems for some installers that happen to sit near the border of a couple of different network operators. They've got different processes with different network operators. They've got different processes with different manufacturers, and then the different manufacturers are using different bits of hardware. So not always catch, sometimes native, sometimes village, sometimes
Yep,
something else. And
that's
all of
right.
a sudden they're needing to be IT experts, communications experts, and all of these other kinds of experts that they really didn't want to be at the busiest time of the year.
Yeah, that's right. And Victoria's quite unique. There's a lot of split phase, two phase in regional areas in Victoria, and it's unique in the world, in fact. So a lot of the inverter manufacturers have actually just said, you know what, we're not doing that. If you've got a split phase site, go to Catch. We can do it, no problem. And the other thing that we're also spending a lot of time on is, of course, people with existing solar systems who are then wanting to do an upgrade. So they're adding a new inverter that's compliant, but they also need to get the old inverter compliant. And there's been a big lot of grey area around this. We, have had it confirmed to us by virtually all the DNSPs now, and a bunch of customers that the DNSPs are saying, we don't care how old the system is that it's in is, it needs to be backstop compliance somehow, which of course is a real challenge, because if you can't communicate with it, or it doesn't have a consumption meter, or we can't connect to it because it's 15 years old, there's a lot of very frustrated people out there say, well, we don't want to throw this away. This system's working great. What can we do? We have a solution, luckily. It's a little bit crude, but we can use the contactor output from our device. We can 485 into the new inverter and then use the contactor to turn off the old device. We've got a testing process that we're going to go through and get it listed and all that kind of stuff. But all sorts of nuances and edge cases and annoying stuff. But like we see with all these games, we'll get there. I
was just lucky, Nigel, in that in my DNSP, an AC coupled battery is okay, and they don't care. Everybody else wants to know about
it. Yeah. AC coupled batteries is an interesting one. We're hearing the same thing. They don't seem to care about them at all.
Which is great.
But yeah, it's great. That's good for anyone who's got a PW or one of the other AC batteries. But pretty much everything else is on the site. You got to get those green ticks or you're in trouble.
You mentioned Powerwall. I'm going to mention Tesla. They've been lighting up the cutters page because you can now buy a Tesla Powerwall 3 or a Tesla EV charger via Bunnings. I did a bit of investigation. For the EV chargers, you buy the EV charger from Bunnings, but they also connect you with a Sparky who can install it within their network. But you actually buy the unit, take it home, and there you go. I put in an inquiry for a Powerwall 3 to purchase through Bunnings, and then I received an email from Tesla saying that one of their approved partners is going to be in contact. They did list the company and suggested what it would look like. So it looks like lead gen to me, which if you're for it or against it, I mean, we've seen it with IKEA. We've seen it with a number of different providers where they go to that lead gen model. What do you think, guys? Is it going to be disruptive or nothing to see here?
I can't see how they're going to make any money out of it. And at the end of the day, it's like any business. If stuff on the shelf's not making direct revenue, then eventually it'll be moved on. In terms of $800 wall connectors, you can still buy one on Tesla's website and they'll deliver it to your front door. I think their service is pretty much as good as Amazon or anyone else. So I don't know why anyone would buy an $800 EVSE at Bunnings unless there was a range of different things there. So if there was other EVSEs next to them and a salesperson could talk to them about one versus the other, and even then, let's face it, you either got a single phase one or a 3-phase one. It's not very complicated.
Or if you're just hanging for a sausage sizzle on the weekend, get your EV charger in a snag as well.
It's a really interesting one because we back in the day, it'd be close to 20 years ago now, but when I was with BP, we did a deal similar to that in Home Depot in the US. It was quite successful at the time. Solar was very different. It was very new, but we actually had a phone in store, and next to the solar panel display was a phone, and you picked up the phone, a green phone, and it just connected you straight through to our call center. And so for us, it was exactly like you said, Luke. It was leads, because the foot traffic that Bunnings has is epic. And so if you can scoop up a small percentage of it, it's really, really nice, and you can generate some leads. Been a number of attempts at it here in Australia, none of which have been particularly successful. Costco had a sniff at it. Bunnings had a few sniffs at solar and hot water over the years, and none of them have really stuck. Having gone through that experience and chatted a lot with Bunnings over the years, they're a pretty tough cookie to deal with because they put you up as a premium brand. They ask an awful lot of you. And an awful lot of money to get that level of profile. And then right alongside you, they will slot a budget brand. And if you aren't performing, you're out, and the budget brand goes, woohoo, I'm up. And then Bunnings charges them a fortune. And they just keep rotating those suppliers alongside each other and drive competition for the shelf space. So
how long till we see Ozito EV chargers?
Exactly.
I'm not joking.
My local Supercheap has EV chargers and EV cables and stuff. So, it's starting to become a commodity item.
And we might save that for the guest who we'll introduce shortly. But one last thing, Nige, there's a warning out in the Northern Territory.
Oh, there is. I stumbled across this one on the interwebs the other day. So Consumer Affairs and NT WorkSafe, no less. So they've got together. So it's about safety and about consumer affairs. Not just a lightweight warning, urging Territorians to be aware of a business selling solar equipment in the Northern Territory. And they named Sunboost, also trading under the names Energenic Solar, Energetic Engineering, National Solar Energy Group, Proprietary Limited, Sunboost, and Syed Zaidi. They call it out for dubious practices across WA, Port Hedland, Broome, Halls Creek, Kununurra, coercive door-to-door sales, unsolicited sales, not providing a cooling off period. They're targeting Indigenous communities. They're trying to sign people up into contracts for financing. They talk about, in some cases, installs provided by Sunboost, which have malfunctioned or failed to work at all. So the Department of Mines, Energy and Industry Regulations Safety in WA has referred Sunboost to the WA Consumer Protection Group for further investigation. As per the press release, the Territorians are strongly advised to ignore.
Correct me if I'm wrong, but they're talking about the largest retail solar installer in the country.
They certainly are.
Ultimately, I'll err on the side of caution on this one and say that if they're operating in places like Broome and Nhulunbuy and so on, those are difficult places to get to. And my guess is that the solar cost in those regions, and it's always been really expensive in Darwin, it's not a particularly friendly place to work, and hence everything's expensive up there. 25 years ago when I lived there, a lettuce was $8, and you're like, well, I'm going to starve to death because I can't afford to buy a lettuce. It's ridiculous, but that's just the way the territory is. So my guess is that someone's paid 25 grand for a 6 kilowatt system, and then for whatever reason a kid's thrown a rock at it and it doesn't work. So we'll see how that one goes.
So it's a good point to bring in the guest. We were talking about EV charging. We always talk about EVs, and it's great to have Ross Rango here. Ross is the head of energy and infrastructure at the Electric Vehicle Council. So welcome, Ross.
G'day, Luke. Thanks for having me on. Pleasure to be on the show, Nigel and Karl. Looking forward to a good chat.
For the listeners who don't know you, do you just want to give a quick introduction to yourself and also your background and how you ended up at the Electric Vehicle Council?
Yeah, absolutely. So my name's Ross. I head up energy and infrastructure at the Electric Vehicle Council. Essentially everywhere where the vehicles touch the energy system in the buildings is where I do my work. I've been at the EVC for a touch over 3 years. Prior to that, I was 13 years at NHP. Background in robotics, automation, machine safety, hazardous area. Last 6 or 7 years doing EV-related stuff.
Nice. It's interesting that, to see guys like you coming out of a more conventional space like NHP ending up at EV. It shows how mature the EV space is starting to become. What's a typical day look like for you, Ross, when you're in the office? What are the things that you are working on?
Yeah, so I suppose that the work of the EVC, it's not a particularly large team. There's a dozen of us, and we do policy and advocacy work with government. So a typical day involves talking to state and federal government folks, either at departmental level or ministerial offices. We do a lot of work in standards, codes, regs, so talking to the folks at the safety regulators, working with Standards Australia and industry colleagues. We had a fair bit to do in the recent rewrite of 4777 around V2G that we'll talk about a bit later. AS3000 is coming in for a rewrite. We're going to be doing a fair bit of work in that. And then the easier part of my job is just introducing people to each other. Membership base of the EVC includes car makers, fleet operators, electrical installers, energy networks, retailers, all sorts of organisations, none of whom can do the transition by themselves. It's a field where introducing people to each other so that the job can be done is really important. So we spend a fair bit of time doing that too.
Nice. Geez, we have to get Kathleen Ryan to come over and work with you. She's the mistress of introductions in the solar industry for 30 years now. So what's going on in the market? Tell us about the market because, apart from the continuous stream of negative press that we have about EVs, the statistics are always of interest to me. There's been talk about a slowdown. Is that real? When do you think it's going to change is a question. And I'd be really interested in what you think is going to be the sort of tipping point for when we're going to see it start to grow at the rate that it was in the last couple of years. What are the numbers telling you, Ross?
Yeah. So I suppose up until this year, over the 3 odd years to 2023, we were experiencing growth at a rate of 100% per year or better in terms of new vehicles sold, right? So real hockey stick exponential growth stuff. This year, we're still seeing growth in sales, but nowhere near at the 100% level, right? The rate of growth has tapered off. Doesn't mean it's slowing down. More EVs are going to be sold this year than last year, but the rate of growth has tapered, and that's what's getting all the coverage up. In parallel with that, we're seeing a real rise in plug-in hybrid sales. So you might have seen the BYD Shark, a plug-in hybrid out of China, launch a few weeks ago. The guys at BYD, they're going to be bringing in pure electric vehicles and plug-in hybrid vehicles. So at the EVC, we consider if you can plug it in, that's an EV. If it's got a recovery of energy from a motor inside it and then take off with that energy, that's like the Toyota hybrids that we've had for 20 odd years. We don't really consider that to be a true EV because the energy is not coming from outside electrical, the energy is coming from petrol. But in terms of the future mix, there's going to be lots of battery electric, there's going to be lots of plug-in hybrid. Very much expecting that BYD Shark crew cab plug-in hybrid ute to be a serious competitor to the Ranger and the Hilux.
In 2,000 orders, though, Ross, isn't really outrageous. I mean, Tesla sell, 6,500 cars a month in Australia. So it's a great start. But we're not setting the world on fire. Setting the world on fire perhaps be 20,000.
Yeah, I suppose I note impressive for day one of one model of vehicle, right? It wasn't that long ago that 2,000 units was the total of EVs sold in Australia in a year. It was 5 or 6 years ago. And now we're seeing a new vehicle enter the market, 2,000 orders on day one. The volume next year of that vehicle, right? What's really going to be interesting to see is to what extent are they successful in taking share from pure petrol vehicles, and time will tell.
And is the charging infrastructure keeping up?
So the charging infrastructure has been rolling out over the course of the last 12 months at a rate probably a little quicker than what the cars are coming on. So the charging infrastructure, if you look at our State of EVs report, has been getting built up faster and faster and faster, and bigger stuff too, right? So a higher proportion of ultra-fast chargers at the 100 kilowatt plus level have been going in. Last summer, we did some survey work around driver experiences because the summer before, we had lots of reports of queuing and broken equipment. Things have gotten steadily better since those reports a couple of years ago, and we're very interested to see what we learn out of surveying drivers this summer. Because that experience at public charges is going to be really important as we move from the early adopters to the early majority.
I've noticed myself, hot days with air conditioning, that the car does use significantly more power than it does when you're not air conditioning. And obviously talk around vehicle to grid, I just struggle to see where people think that they're going to make some kind of cash out of their EV. I think that their energy is worth what they pay for it, 50 cents, 60 cents a kilowatt hour at 8 o'clock at night, when I think the reality is what we're seeing on the grid is that energy at those times isn't particularly valuable outside of a couple of spikes. And the hardware looks pretty expensive to me. What's your thoughts there?
So I suppose a couple of bits there. The first one you touched on around energy consumption when you're running the air conditioner. 100% different driving profiles and different usages will consume different amounts of energy per distance travel. This is exactly the same as what you get in a petrol car. If you've got a Land Cruiser and you're driving, that'll consume a certain amount. Start towing something that weighs 2 or 3 tons and you'll consume a lot more. If I consider my wife's EV, it's a Polestar. We live in Melbourne. If I drive to Kyneton, it'll consume almost twice as much on the way out there as on the way back, because there's a 500 meter elevation to get there and you've got to pay in energy to go up the hill. Turn the air conditioner on, it'll use more. But I would note that regardless of air conditioner, the range in the car is sufficient to get there and back. So depending on what you're doing, not necessarily a drama. Picking up on the V2G piece, so V2G as a concept has been around for a very long time. There's been trials all over the world over the last 10 years. So there's been a lot of noise about it. Minister Bowen was in the press about it. Obviously, myself and my team, we've been working on the Standards Australia side and with the CEC for some time to prepare for it, to make sure the inverter and electrical side of the mix is ready. The question as to what is it worth to the consumer to participate is one that we're going to discover over time. The idea of V2G, the reward available to the consumer, stems from, is there a difference in wholesale price? So is there a value stream available at peak time in the afternoon that's different to the off-peak price or recharging with your own solar panels? And is there an avoided network augmentation on the energy networks, which comes through to the consumer by way of the network tariff component of the energy bill?
These new standards are already written into AS 4777. So what did Chris Bowen actually announce? Was there anything that actually changed?
the requirements from here, right? What needs to happen from today in order for vehicle-to-grid equipment to be available in market? 4777's been published. The Clean Energy Council are updating their approved inverter framework, which is going to be necessary to enable certain kinds of vehicle-to-grid inverter to be approved by them. The DNSPs then refer to the Clean Energy Council's approved equipment list. And obviously, once the equipment's on that list, then the equipment importers and manufacturers need to bring it in. So in terms of what actually changed on the day that Chris Bowen made the announcement, not a great deal actually changed on that particular day. That standard had been published. The Clean Energy Council is working on their bit, which is the next stage gate. And then the equipment manufacturers need to get their products listed and bring them in. Very much expecting existing solar and inverter manufacturers to be a big part of that mix.
There's two levels of thinking here. One is, am I driving around with the hardware, or is the hardware going to be bolted to the wall? And a couple of major inverter manufacturers that I've spoken to, they seem to think that it's going to be driving around in the car and not bolted to the wall at all. And then obviously you've got inverter manufacturers that are saying, no, it'll be bolted to the wall. So it'd be interesting to see which technology gets up there too.
Yeah, and I'm really intrigued by this, Ross, and keen to hear your view on this, because everyone's excited about it. It's the concept, it's the principle of being able to use that's getting everyone hyped up, which is exactly what happened with solar. It's exactly what's happened with stationary batteries as they started to grow. And you get early adopters who come in and go, this is just so cool, I just want to do it because it's cool and the price doesn't matter as much, and they're willing to take a bit more pain to be an early adopter. What I'm interested to know from you is, what are you hearing about manufacturers of the technology? Because at the moment there's a pretty small pool of technology manufacturers. Obviously this is going to place the hype and the hyperbole and the high solar penetration we've got in Australia is going to make us ground zero for this technology, I would think. What are you hearing about on the manufacturing side and the supply side? Are you being smashed by people that were saying, how do we get involved and how do we get our product into the market, or is it still early days?
Yeah, so I would say there's certainly a lot of people interested. And if Minister Bowen's announcement did nothing else, it got a lot of people talking about it and focusing up on how big is this opportunity, how close is it, what do we need to do next? To Karl's point about where does the inverter sit, the inverter can sit on the wall or in the car. It's possible for the vehicle to export AC. It's possible for a car maker to make the vehicle able to export grid synchronized AC. The question's really one of, what are the technical compliance requirements in the inverter, and is the car maker going to do all that work in order to achieve compliance to things like fault ride through, harmonics, all of that kind of thing? Or is it going to be easier for that compliance to be done in a box on the wall? Very much two schools of thought on that. There's no reason those things can't coexist. It's probably going to be easier from a reg compliance standpoint for it to be DC out of the car to a box on the wall first, just because that allows for all of the technical needs that any DNSP might put on the inverter to be in a box on the wall. Makes it something the car maker doesn't need to worry about and incorporate within their thing on wheels. Also perfectly possible that the future involves a box on the wall that inverts the DC from the solar into AC when the sun's up and takes DC out of the car when the sun's not. So there's a future possibility there where it is one inverter on the wall, not two, and your solar inverter lives in the garage and grows a cable that plugs into your car. The car makers are going to be critical to this, because unless the car makers enable the vehicles to export energy, then V2G is a non-starter. So one of the critical elements is, what do the car makers do? What we're observing overseas, the team at Arena have funded some work done by a guy by the name of John Sibley into this, and they've looked at what are all the car makers interested in, what are all the car makers' roadmaps. Some of them are looking at AC export from the cars, some of them are looking at DC. Many of them have got product launches imminent. And one of the things that's really interesting out of Europe is inverter manufacturers taking stock standard EVs that are available in market, where the car makers have made no announcement regarding V2G whatsoever, plugging the cars into the inverters, pressing the button and finding out that it works just fine. So there's a lot of car makers out there that have built product that's already doing the job. They just haven't made the announcements yet.
This is a really good one because, US Minister of Doge, Musk, has been adamant that Teslas were not going to be bi-directional, and I haven't heard anything from them. And of course, I would expect that if anyone's got the technical capability to do it and the ability to build the ecosystems and everything else, it would be them. Are you hearing any sniffs about what their attitude towards this is?
Yeah, so I will refrain from speaking on behalf of a specific manufacturer, right? What I would observe is that you're correct. If anyone's capable of doing it, it's those guys. The thing that I would be watching for is which car makers announce first, which ones are fast followers. Without question, there are going to be car makers in market next year that are supportive of it. Exactly which ones and when, there's going to be stiff competition around that.
Yeah, my concern there, Ross, is my old Tesla Model S done 230,000 Ks now, and it's only done 450 cycles on the battery. And if I was to have brought 10 kilowatt hours of electricity home from my workplace every day to run my house overnight, I would have added another 300 cycles to the battery, and I would be, instead of somewhere around 12% degradation, I'd be at 18% degradation. And at 18% degradation, it's actually not as practical as it was. And a bit of research tells me that 1,000 cycles out of it is looking pretty lucky at, say, about 500,000 Ks. But if I only got 300,000 Ks out of it because I was bringing home 10 kilowatt hours a day, would probably discourage me from going down that path, simply because, being 8 years old, I can't buy a new one, or I can't buy a replacement pack. And as the technology evolves, sure, newer technology batteries are less expensive, but they're not retrofittable into an older car. And certainly manufacturer A's battery doesn't fit into manufacturer's B car. So I think it's not unreasonable to say that the average life of a car in Australia is 185,000 Ks, and the battery will exceed that. But I think that EVs are going to last a lot longer than that. They're probably going to last more like 400,000 Ks, at which point vehicle to grid starts looking like actually impacting the life of the car. What's your take on it?
Before you answer that, Ross, I'm going to jump in with a counter for you, Karl, because I love that you've done the maths on that. That's just beautiful. I'm probably typical of the average dumb, lazy Australian, though. And, I've got an EV. I'd love to V2G my EV. I do bugger all kilometres on it. It spends a lot of time at home because I work from home, like a lot of people do. So I don't do a lot of Ks on mine, and I'd be quite happy to pay a lifetime price to be able to utilize that, because, and in my case, I happen to be a renter as well. But, irrespective of that, if I could utilize that electric vehicle as storage, I'd be chomping at the bit to do it. And I couldn't give two hoots about the impact on the life of it.
The LiveWire's got what, 25, 30 kilowatt hours?
15.
15. So at the end of the day, your grandkid's probably going to be putting a new battery in it because you're never going to sell it.
That's fine.
And a new battery in 25 years probably be better than the one that's in it anyway.
Exactly. Happy days. Kill the thing. Work it hard. Use it to the bloody inch of its life. Come on, Ross. Tell us which one of us is right, which one of us is wrong.
So I guess first up, battery degradation when you're cycling a battery for V2G. Not surprisingly, a lot of the trials internationally that have looked at V2G have been looking at that, because you're spot on. If you cycle a battery more, you will wear it out a little bit quicker. The question is, how much quicker? The question is it meaningful in terms of the life of the car? What's been discovered is that because V2G is not using the battery at particularly high power levels relative to what the battery is capable of, so the battery in the car is capable of full acceleration of the car, right? 100 kilowatts plus. V2G is not going to be anywhere near 100 kilowatts because you're constrained by what the house can handle, right? V2G is going to be more like 5 or 10 kilowatts. And it's usually going to be in the middle range of the battery, while the battery is in a state of charge between 20 and 80%. So it's relatively gentle. And that's been borne out in tests. What people have found overseas is that V2G, even when you're doing it pretty heavily, doesn't do much in the way of degradation to the battery. The other thing I'd pick up on is something that you mentioned earlier, Karl, that the bulk of the value is only available in a few trading intervals. One possibility is the person's drawing in 10, 20, 30 kilowatt hours every day and discharging it every day. The other possibility is they're following something like an amber wholesale price pass-through signal, and they're only actually doing V2G on those days where it's really highly valuable. So the volume of energy that's moving back and forth isn't actually all that huge. They're just trading the really high value intervals. Now, obviously, that's not going to be every consumer. That's your engaged consumer. It's guys like Nigel, but it may be that the early days looks like that. The other part that will be relevant to that is what the car makers do. So ultimately, the car maker holds the warranty on the car. If they're selling a vehicle with a warranty that's got 8 years coverage and 160,000 Ks on the battery, and they're making vehicle to grid possible, they're the ones that catch it in the event that you trash the battery inside that 8 years, 160,000 Ks envelope. So you can expect that car makers who choose to enable V2G will set limits within the vehicle on what that vehicle's capable of when you're using it for that mode in order to keep the battery within warranty limits.
And maybe the warranties are going to look more like home battery warranties, where you talk about cycles, you talk about, what that degradation is over that period of time, as opposed to just having kilometers and set years.
Yeah, that's right. So if you look at the warranty for a typical EV, it's 8 years, 160,000 Ks, 80% state of 80% capacity as measured against original. It's those sorts of terms. They're not all the same, but it's the assumption is baked in that once it gets to a certain age or a certain number of kilometers, there will probably be degradation. It's a question of how much is acceptable. And if it's degraded more than that, then the car maker owes you a free battery, which is why they're going to be particularly interested if people are doing V2G as to exactly what that behavior looks like so they can make sure they're not wearing excessive warranty costs.
Well, my experience with, having a play with these sorts of things, I posted a bit to NEM Watch today with my own system and exporting 120 kilowatt hours to the grid and using 60 kilowatt hours for the day. And someone said, wow, you've really managed to bend the rules here or use the network to the maximum of its capacity and capability. This is a real worry for network operators as a whole if everybody does the same thing. Ultimately, I think those people that are going to test out the technology are going to buy high-powered equipment. I think that if it was going to be worthwhile to take advantage of those expensive events, that I'd want to be discharging the car at 25 kilowatts into the grid. Similarly, in those times when, we were standing at the standard all energy and it flashed up on the screen that the network rate was negative 47 cents. So, of course, I want to be able to charge my car at 100 kilowatts when that time comes around, because those times only last for perhaps 30 minutes.
Yep. Oh, look, the rate of power essentially is going to be defined by the equipment. Your equipment's going to scale in cost as a function of how powerful it is. And there's a balancing act there of what equipment do you choose to buy. The market will find its level, I would expect.
Ross, what do you think the ratio is of proper AVSEs out there versus things that plug into the normal outlet?
If we're talking about just straight up charging the car, not so much V2G, from what we've seen, it appears that you've got a majority of consumers today who are just plugging into a standard 10 amp power point for charging their car. And I don't mean a huge majority, depending on which numbers you read, somewhere in the 50 to 70% range are along those lines. That's happening because a standard 10 amp power point is capable of delivering about 120 Ks of range into an EV in an 8-hour period. And most consumers don't drive that much. If I look at the arrangement that I've got at my place, I mentioned my wife's got a Polestar. I've got an Outlander plug-in hybrid. We have one off-street car parking space at the house, and it's got a 10 amp power point that feeds both cars because that's all we actually need. All the EV charging happens off-peak. I live in Mini Ponds, work in Brunswick. She lives in Mini Ponds, works in Sunshine. It doesn't actually take high-power equipment to meet the transport need. If we were doing V2G, we would want significantly more than 2.5 kilowatts. So V2G would probably be the trigger to actually install something more powerful so that we could move more energy back and forth in the time.
Yeah, I'm at the opposite end of that scale. I've got two 22 kilowatt chargers in the garage, and I'm on the OVO deal where you get free energy from 11 till 2. So even if I'm making 20 kilowatts worth of solar, I want the house to be running at 30 and getting 10 for free. This time of the year, it's tough. I can do it for about an hour before everything's fully charged and fully heated and fully air conditioned, but that enables me to take the car away on a Saturday and go and do a car meet somewhere that's 100 Ks away or 150 Ks away, take the car there, bring it back, and it still needs to sit on the charger for 6 hours, even at 11 kilowatts, to recharge the car after one of those sorts of trips. So unfortunately, sounds like I'm using a shitload of power.
Question of how much power do you need in order to be able to meet the mission, right? So if I think about someone like an Uber driver who's doing 300 kilometers of driving each day, for argument's sake, that person is probably looking for 50 or 60 kilowatt hours each night to go into the car. So if they've got 7 or an 11 kilowatt charger, that 7 or 11 kilowatt charger is going to run for several hours, topping up their daily drive every day they drive. A 10-hour power point is not going to cut the mustard for those folks. They're going to need a proper EV charger. And really, it's just going to be a mix of what does the consumer want, and that'll be what they install.
Speaking of Uber drivers, I think that's an interesting segue back into the V2G space, because I think it's pretty inevitable that the initial people who are going to take up V2G are going to be your early adopters. They're going to be people who like to play the wholesale market, like Amber and those other kinds of things. How likely is it, do you think, that some of those higher power public charging stations or corporate EV charging stations, which are starting to pop up all over the place, are going to move into this space so that they can V2G vehicles during the day rather than it being a sort of homeowner gig? Do you see that as being a big part of the mix, Ross?
So there's a V2G public installation going in Adelaide at the moment. I don't think they've quite cut the ribbon on it yet, but it's been all over LinkedIn. People should be able to find it if they're interested. There's also public charging infrastructure being installed on power poles around inner suburban suburbs in New South Wales. So AC chargers going in on power poles, principally aimed at residential areas where there's a lack of off-street parking. So think terrace housing, worth quite a bit of money, green leafy suburbs, people lean left, vote green, buy EVs, but don't have somewhere off the street to park the car. I think it's possible that things like power pole mounted EV charging will go towards V2G, because the use case is the driver goes to work, they come home, they're plugging into a power pole in front of their house at 5 or 6 in the afternoon. No one wants them consuming energy at that time because that's peak time, but it's certainly possible they could be paid for discharging energy at that time and then recharge in the small hours of the morning, where ultimately in future, the wind turbines are spinning against not much load. I can see a case there where, because the vehicle is parked in the location anyway, and the economics will reward discharge at that time and then recharge later, that the person driving that car might well plug in at that asset and ultimately end up cost neutral for their daily fuel, because the discharge is worth more than the recharge plus the kilometres driven.
Does it sit with a private company to operate that? Does it sit with the council?
So that power pole mounted charging infrastructure, you've got obviously the energy network owns the pole. They do a facilities access agreement with someone to mount the equipment to the pole. And this is being done under a grant scheme supported by New South Wales government. And obviously local council's got to be involved because they own and manage the places where the cars are being parked in front. So it's a three-way arrangement between the charge point operator who owns the kit, the DNSP who owns the pole, the local councils whose streetscape it is, with the money in the back end coming at this point under grants from state government, being New South Wales. And there was one a little bit earlier where the money come from Arena. Same idea though.
I reckon you could get a lot of the benefit of V2G with the existing technology and high-speed chargers with the cars that we've got. So as an example, if a number of energy retailers are already doing it, you plug the car in and they charge it when it's convenient for them, and you pay an otherwise lower rate. I'd sign up for that if it was a case of whenever you charge your car, we're going to pay you to take the energy. I see it on the NEM all the time, energy rates in negative territory. I don't generally leave the cars plugged in all the time, but I would be prepared to plug it in all the time if that was economically viable for me to do so, rather than me doing it at my choice. That therein begs the question, am I making the choice to discharge the battery at some cost of convenience? Kid wakes up in the middle of the night sick and I go out to the car and it's at 10% because it's 20% because it's discharged to the grid. There is a cost of convenience there at some point. So do I give them a narrow range of parameters to work with? But anyway, I think that we've already got Charge HQ. Charge HQ is looking at grid costs. It's looking at what the user wants. It's looking at renewables content. And I think that a lot of the things that we hope to achieve with V2G, we can already achieve with all of the cars that are out there with the existing hardware without having to buy any fancy gear. We can get 90% of the benefit with what we've already got.
Certainly the benefits associated with EVs charging at the right time are huge, and you're spot on. They're not difficult to achieve. The cars can be set much the way you set a radio station in your car to choose when it's going to charge and what times to avoid. As you said, you've got Charge HQ, Origin Energy have a good plan that orchestrates by way of the car. Lots and lots of ways to do it. The V2G bit is just that extra cherry on top of now, instead of just presenting it as a really flexible and orchestratable load, we can also treat it as something that is a source of energy at time of peak demand. To that question around what about the convenience, what about the amenity loss? Anyone who is accepting orchestration of their vehicle, whether it's for charging or discharging, ultimately that's going to have to be a deal that works for the consumer, because if it's not a deal that works for the consumer will choose not to participate. V2G especially, if I'm handing over to a third party the ability to discharge my car into the grid, I'm not going to do that unless I am able to set a floor level below which it won't discharge. I'm not going to do that unless I've got the ability to say, actually, no, today I'm not participating because I need that vehicle at midnight because I'm doing a thing. The consumer's ultimately going to be in control of systems like this because they won't work otherwise.
We have a slider in our app that is designed to solve exactly that problem. So you can say, yeah, sure, charge my EV or discharge my household battery, but I always want this level of reserve. And you have to give the consumer that choice. And I can see us, in fact, we've been talking about how we'll participate in this and use those same consumer controls and put that, consumers want that level of control.
Ross, a lot of our listeners are solar retailers and solar installers. A lot of them are already offering EV chargers for their customers. Where do you see the opportunities for them going forward?
So I'd say there's on the order of 250,000 Australians driving around in EVs already. Clearly, a lot of solar installers have been on the front foot and have adjusted to incorporate EV charging within their business models, which is great. Pretty logically, the sorts of consumers who have been early in solar or big in solar are exactly the same sorts of people that are likely to be early adopters of EVs. So there's a natural market fit there. I would say understanding the consumer's actual need is really, really important. So if you're a solar installer and you have not had the personal direct experience of driving an EV, go get yourself an EV and learn what it is all about firsthand so that you're approaching your customers from obviously working with the EV council. I'm going to say go buy an EV, right? But I'm not saying you have to buy one in order to experience it. You can go rent one for a week. You can test drive one. You can ride in the back of an Uber next time you're catching an Uber, pick an electric one and talk to the Uber driver. But get yourself some practical experience from the customer's side of what they're going to need in order to wrap your head around it. That's probably lesson number one. The next bit would be, if you don't already have the experience of doing installations and you're looking to do a course or learn about this kind of work, the EVC, along with the team over at NECA and Energy Safe Victoria and Centre for You, work together on a Victorian-funded training program specifically aimed at helping electricians upskill in terms of what do you need to know in order to do EV well at a domestic level. That training program's available through Homeschooling. It's available through Centre for You. Not available outside Victoria yet, but probably will be at some stage soon. If that one's not available to you, then maybe look up what training courses are available. Pick up some knowledge around the area in order to equip yourself to do a better job with it.
I also want to throw in a shout out to the Electric Vehicle Council and the great work that they've done. I dug around in there the other week, looking through all the reports and stuff that you guys have created, and there is a ton of information. So again, the other part for the solar industry is that the work that Ross and the rest of his team have done in actually compiling all this information, getting all these reports together, getting the latest data together. It's all there, and it is a wonderful resource for people to understand that industry really, really well. So, nice work there, Ross.
Absolutely welcome, Nigel. I'd say if anyone's looking for that stuff, jump on our website, look under publications and guidelines. That's where we put the technical stuff for the trade. If there's something that you want to know about, if there's a guideline that you reckon it'd be really good if we written to help unpack something or explain it, drop us a note, let us know. I'm not a difficult person to find. Maximum demand in particular is going to be an interesting one for a lot of installations, right? So without wanting to go too far into the detail, in AS3000, there's a few ways to work out maximum demand and connection size. Some of those ways will lead you to a network connection upgrade, others won't. So it's worth having a bit of an understanding about that. And to Nigel's point, we've got guidelines about that stuff on our website.
Interesting on that. I've got one that smart EV charger, which looks at the mains and will throttle its output, and the other one doesn't. And that really did change my views on managing customers' maximum demand. I can quite easily exceed mine with all the stuff that I've got in the house. And of course, exceeding it means that I've got to walk outside in the rain on a cold day to turn the power back on because the main switch is tripped off. But I've got 120 amps of supply in total, and obviously standard single phase connections only 63, and I can see all electric homes tapping that out very readily, particularly if they've got an EV charging. And of course, the number of customers that I've spoken to that have had issues with customers who have got on the OVO free deal 11 till 2. They want to charge their home batteries, they want to charge their cars, they want to heat their water, they want to heat their house, and all of a sudden they're melting things on the pole in the street.
If only there was a piece of hardware and software that you could set the demand limits on that would manage all that.
Oh, Nigel, you've done your quota, Nigel. Catch power, check it out.
If only someone had a piece of kit to sell that'd do that job.
If only. Oh my goodness.
But to your point, Karl, that's a very valid point. In a typical home, if you've got 63 amp single phase and you're putting a 32 amp single phase charger in the garage, that's half, right? If the person's cooking dinner and running their air conditioner, then running their EV charger at the same time as doing that is going to make them reach a limit. There's an education piece there that if you are installing a single phase EV charger in the garage and you're choosing not to upgrade the consumer mains, the consumer's got to be brought to an understanding of when it is an okay time to use that piece of kit. And if they get it wrong, what's going to happen in terms of their need to reset the breaker. Yeah, doesn't that mean that every home needs a three-phase upgrade? It means that some consumers are going to need some education.
Yep, I like that. I like that approach, Ross. And the interesting one there is cooking dinner, and it only takes 8 minutes to cook a steak well done. And there's no way you can run your stove at 11 kilowatts to cook a steak for that length of time because you've turned it into a charred mess. So I think that the cooktop is okay. It doesn't matter what else you've got. You just can't run it for long enough.
All right, gents. Well, there's not time for much more, so we're just going to have a quick whip around for last thoughts, and we'll start with you, Karl.
One of those episodes where I'm excited. It's great to have Ross on. Obviously, we've seen him at lots of industry events, and he speaks very well to the topic of EVs. It's not often that I ring yourself and Nigel before the podcast to say, hang on, this one's going to be a really interesting episode. So thanks very much, Ross. It's been great to have you on board. And we look forward to lots of changes in this space. I think we're still very early days. Perhaps we're at BlackBerry level in an iPhone 7 world, and there's got to be a lot of evolution of cars technology and cooperation between all the different parties to make it work properly. But it's good turf for the early adopters for sure.
Very good. And last thoughts, Nige?
How lucky are we that we just get to play with the best shit? This is the thing that strikes me is yet again, Australia, every year in 32 years of solar, every single year, you just go, oh my gosh, we're going to be leading the world in this or in that, or we're doing this in a way that no one else has really done. We're just like this perpetual, very worn out canary in a coal mine. I just think it's wonderful and, lucky us.
And Ross Rango from the Electric Vehicle Council, it's been great to have you on board. And just to remind listeners that if you want to check out their resources, if you have any questions or anything to do with training, just jump on the website, reach out to Ross, and they'll be able to help out. Ross, any last thoughts before we wrap up?
Just to thank you for having us on the show. Much appreciated. We spent a lot of time talking about V2G. I suppose I'll close with a quick parallel. So in 2006, there were about 1,100 solar installations done. 5 years later, 2011, there were about 350,000 solar installations done. So it went up like a rocket off the back of some government intervention. 2025, 2026 is looking like being that 2006 year for V2G. So the question for us as an industry is, what does 2030 look like? What does 2035 look like? That's kind of what we've got our sights set on. The question that I throw to system planners is, in 2035, from V2G, how many gigawatts would you like?
Well, thanks again, Ross, and thanks to you for listening. Please remember to like, subscribe, share it round, and we'll catch you next time.